Welcome to BSc Statistics students. So in this class I explain problem number 2 in PERT, Project Evaluation Review Technique. So these are the activities which are given here, and also these are the activities A, B, C, D, E, F, G, H, and immediate predecessor, that is predecessor activity, is also given here, and estimated times in days, in number of days which are given here. And with this data we have to calculate first question, calculate expected time and variance of for each activity. Second one, network diagram. Third one, critical path. And fourth one, expected project length and variance of project length. And fifth one, what duration will have 95% confidence for project completion. So these are the questions you have to answer, for which what I am calculating for every activity, I am considering optimistic time and T naught, and most likely time Tm, and pessimistic time Tp. I consider these three activities, and then I calculate these values. These are the values. The first question is going to be answered in this particular table. I have prepared table. This is the table you have to calculate the times. Okay, with these values, the T naught, Tm, and Tp, which are the values, are given. I write the values: T naught 1, 1, 2, 1, 2, 2, 3, 1. Tm, the values are given here: 1, 4, 2, 1, 5, 5, 6, 2. And Tp, the values here: 7, 7, 8, 1, 14, 8, and 15, 3. So these are the values are given here. We have to calculate expected time, that is Ta, with the formula T naught plus 4 Tm plus Tp divided by 6, and the T naught here 1, 4 into Tm, Tm is 1, 4 into 1 plus Tp is 7. So divided by 6, the values. If you do the values like this, we get the values 2, 4, 3, 1, and 6, 5, 7, 2. You please calculate the values by using this particular formula. You will get the expected time, right? Similarly, sigma square is the variance, expected variance of each activity. For each activity, you have to calculate Tp minus T naught divided by 6 whole square. Tp is 7 minus 1, 6. 6 divided by 6, 1, 1 whole square is 1. Like that, you have to calculate all the values. You will get the values 1, 1, 1, and 0, 4, 1, 4, and the last one is 0.11. So these are the values. Ultimately, the values are expected times and variance, expected variance we have calculated for each activity. What are the activities? A, B, C, D, E, F, G, H. Right? These are the activities, and for which we have calculated expected time and variance. And then what you have to do, this is the first question. The answer for the first question, calculate expected time and variance. And then now you have to draw the network diagram and find critical path. These are the two questions we answer by basing on the given data. Now if we consider this question number 2, network diagram. The network diagram is going to be drawn, right? So while considering the activities, for A, B, C, there are no predecessor activities. You observe here, this is what the data it is given. Before A, there is no activity. Before B, there is no activity. Before C, there is no activity. Immediate predecessor means before this, there are no activities. A, B, C, we have to draw, right? I am drawing three particular activities by considering the respective nodes or the events, right? So I consider I'm starting with the event 1, and from 1 to 2, I consider one more event 2, and so that I draw the event 2 here like this direction, and I consider this is A, and I draw B in this direction, and so that I consider this is the third event and this is the activity B, and then I consider the activity C in this direction, and so that I consider the event 4, and 1 to 4 I consider the activity C. I have considered 1 to 2, I have drawn 1 to 2 the activity A, 1 to 3 activity B, and 1 to 4 activity C. And after that, what you have to consider? You see, the further, before the activity D, A should be finished. The predecessor activity of D is A, and the predecessor activity of E is B. That is, before starting E, the B should be finished, and before starting F, C should be finished. The F activity is going to be started after the activity C. Right? Do these. Before D, after A, D, after B, E, after C, F. Okay, so that I consider in this fashion. First of all, I draw after A, D. After A, we have an activity D. Let it be, that is one particular node I am creating here, and so that let it be this is D, the activity D. Okay, and I draw the activity E with the help of B, but any kind of relation, other relation also I see the relations, so that I draw the activity E. That is activity E. That is, you see here, after C we have to draw F. Okay, and after G, that is before G, I'm sorry, before G, the activities D and E, the two predecessor activities are going to be existed. So therefore you have to draw before G, D and E should be finished. But if you see here, E should be started after the activity B. E should be started after activity B. After B, E should be started. So I am joining D and E activities like this. This is the activity E, and after D and E, you see, you observe, probably you can easily observe, after D and E, G, the activity is going to be started. That is, for G, predecessor activities are D and E. And you see, D and E are finished, and then I am drawing the activity G. I am drawing the activity G like this. So, okay, this is the activity I'm considering as G. And after C, the activity F is going to be started. This is F. F, the predecessor activity for F is C. That is, after C, F should be started. And one more relation for G and F. You see here, the last one. After F and G, H should be started. Of course, H is an end activity, last activity. Before H, F and G should be finished. This is what G. Okay, this is what G, and therefore, if you finish F here, the activity F, G and F are finished, and then H should be started. That is, the activity H should take place. This is what the activity H, if I consider, so that all the restrictions, all the restrictions are going to be fulfilled, right? Which are called restrictions or constraints. The constraints are, all constraints are satisfied. You see here, before A, B, C, there are no predecessors. Therefore, A, B, C are starting activities. I have considered in this fashion. And then after A, we have activity D, and after B, we have activity E. That is, for D, predecessor activity is A. For A, predecessor activity is B. For C, for F, predecessor activity is C. So, C is finished before starting F, B is finished before starting E, A is finished before starting D. And then G is the activity. Before that, predecessor activities are for G are D and E. Therefore, D and E are finished before starting G. Okay, in this direction I am considering G. And then one more condition or restriction, that is, before starting H, the predecessor activities are G and F. G and F are to be finished before the activity H. Therefore, G and F I have joined here, and then H I have started here. So therefore, now I give the numbers. This is 5, let it be. This is 6, and let you consider 7. So there are 7 events I have considered to draw this particular network diagram, and so that this is the network diagram for the given problem. Hope you understand. This is what the network diagram. And from the network diagram, the third question, critical path, it is going to be answered, for which you have to calculate all E and L values, that is earliest times and latest times, are to be calculated with the help of the forward pass calculations and backward pass calculations. So that I am considering E2 L2 here. I am writing for at every particular node or event, I am writing the values of E and L. This is E3 L3, right? And then you write here E4 L4, right? And then for fifth node, I am considering for fifth node and fifth event E5 and L5, right? Which are finished. And then for sixth activity, you consider it is, I'm writing here, okay, yeah, E6 and L6. And then last one, seventh node, end node, E7 and L7, right? So now I start the forward pass calculations, and then I calculate, by using that I calculate earliest times, E's, okay, EI's, you can consider EI's. So I quickly start simply by taking the values, adding the values of E with Dij, we can calculate the values. I am considering E1 is equal to 0, and what you have to write is time periods, time durations. The time durations are to be considered, which are to be considered with the TE, time estimates. That is, this is the column you have to consider for the activity A. The time duration, the time expected time is 2. Like that, we have to consider all these time values. I am writing here in the network diagram that A is of time duration is 2, and B the time duration is 4, and C the time duration is 3. Similarly, remaining all I'm writing here from the table. D is 1, E6, and F5, and G, G is 7, and H is 2. So these are the values here, and so that we have to consider the E's, and you have to calculate earliest times first. By I am considering E1 is equal to 0, and 0 plus 2, it is equivalent to 2, because we have only one connection, one connector. And coming to the third one, E3, and 0 plus 4, that is E plus D, 0 plus 4, it is equal to 4, and E3 is 4. And coming to the fourth node, fourth event, 0 plus 3, we have one connector again here, 0 plus 3, it is 3. And coming to the fifth one, we have two connectors, and therefore you have to calculate values and take maximum. 2 plus 1, 3, and 4 plus 6, 10. The maximum is 10. So right, this is 10. And coming to the sixth one, we have two connectors, and with coming from 5 to 6, 10 plus 7, 17. And coming from 4 to 6, 3 plus 5, 8. Hence it is 17, the maximum. And for the last one, we have only one connector, 6 to 7. Therefore, 17 plus 2, it is 19. Now coming back, these are the forward pass calculations. Therefore, the time of completion, estimated time of completing the project is 19 days. This is called TE. Okay, we'll answer there. And now coming back and calculating the values of latest times, which are to be calculated from the backward pass calculations. The first assumption is for last event, that is seventh event, E is equal to L, that is 19 to be considered for L7. That is, and coming back to the first node till the first node. Now after 7, sixth node or sixth event. which is to be considered only one particular connection. Then 19 minus 2, it is 17. And then coming back to the fifth node, fifth event, the values are going to be considered here. L 17 minus 7, it is 10. And coming to the fourth one, only one connection, and 17 minus 5, it is 12. Okay, and then coming back to the third one, we have again only one connector, therefore 10 minus 6, it is 4. And coming back to the second one, again we have only one connector, 10 minus 1, it is 9, right? And then coming back to the first one, obviously it is 0, I have specified many number of times. Again we calculate 9 minus 2, it is 7. And then we have to consider minimum. You have to calculate all. 9 minus 2, 7. 4 minus 4, 0. And coming back to the here, 12 minus 3, it is 9. So minimum value is 0. These are the backward pass calculations, and from which we can easily identify the critical activities and critical path. The first of all, critical activities. What are critical activities for which E and L are equal? The earliest times, latest times are equal, and for the nodes and if the connector connector having both the nodes having the values E and L are equal. E1 0, L1 0, E2 L2 not equal, E3 L3 equal. Therefore, E1 1 to 3, it is a one critical activity. 1 to 3 is a one critical activity. And then you see 3 and of course 4 not equal, and 5 it is equal. Therefore 3 to 5, that another critical activity is 3 to 5. E3 L3 equal, E5 L5 equal. And coming to the sixth one, E6 L6 equal, E5 L5 equal. Therefore 5 to 6 we can consider it is another critical activity. And then 6 to 7, of course, E6 17, L6 17, and E7 L7 are also equal, 19 19. So therefore this is the another critical activity. Therefore the critical activities are 1 to 3, 3 to 5, 5 to 6, 6 to 7. That's therefore critical path. The third question is going to be answered by critical path. Critical path of this particular problem is it is 1 to 3 and 3 to 5 and 5 to 6, 6 and 6 to 7. So this is the critical path: 1 to 3, 3 to 5, 1 to 3, 3 to 5, 5 to 6, 6 to 7. This is the critical path, the answer of the third question. Now the fourth question. The critical path we have answered the third question, and then you see the fourth question: calculate expected project length and variance of the project length. So first of all, expected project length, I already specified that the expected project length is going to be calculated, obtained from the last node, from the last event, the value of earliest time E, that is 19. Therefore the expected project length, this question is having the two questions. Expected project length is 19 days, because it was given in days, and expected project variation, that is variation of the project variance, or we consider variance, project variance of the project length. What is the variance of the project length we are doing, right? Which is for which what you have to do is you have to see the critical activities. What are the critical activities? 1 to 3, it is B, E, G, H. 3 to 5 is E, 5 to 6 is G, and 6 to 7 is H. So B, E, G, H, these are critical activities. B, E, G, H, which are all critical activities. For these critical activities, what you have to consider, the variance. You see, observe here the variance for each activity. It is specified, given. We have calculated, not given. It is which are calculated. For B, this is the variance, and for E 2, 3, and 1 2 3, yeah, this is 4 is the variance for the activity E, and for activity G 4, and for activity H it is 0.11. If you add these variances, you will get the variance of the project length, which is 1 plus 4 plus it is equivalent to be 1 plus 4 plus 4 plus 0.11. It is this is denoted by sigma square E. The value is 9.11. So this is sigma square E, right? So these are the values in the fourth question. Expected project length 19 days, and variance of the project length, expected variance of the project length is sigma square E is equal to 9.11. These are the answers. And then now we have to go and answer one more question, the last question, fifth one. I answer the fifth question here. Okay, I answer the fifth question here. What is fifth question? You see, what duration will have 95% confidence for project completion? To complete the project, what will be the duration for having the 95% confidence? That is 95% chances of completing the project. What would be the duration is going to be taken? What duration is going to be taken, right? That is what we have to calculate. So 95% confidently, that is with the probability 95%. We have to consider in this way, the probability of Z is less than or equal to Ts minus Te divided by sigma E, which is going to be considered as 0.95. 95% confidence for completing the project. To do the question, you have to consider 0.95, 95%, for which this is what the Z, where Z is equivalent with standard normal variate Ts minus Te divided by sigma E, for which Ts is nothing but scheduled time. That is what required to calculate. That is Ts is equal to how much? That is only the question now. What you have to answer in this question? You have to answer Ts. You have to calculate Ts. So Ts is how much? That is our question. What duration will have 95% confidence for project completion? To complete the project, what duration, how much duration is going to be considered for 95% of chances of completing the project? That is here Z and Ta, that is Ts, and Ta, it is the estimated time of completing the project we have calculated, that is 19 days we got, and sigma E, that is also we have calculated, sigma square E we have calculated, and so that I am writing all the values. And before that, I finish one more, that is one more particular work here. The probability of Z less than or equal to Ts minus Te divided by sigma E. For example, you consider this is Z. This Z value is going to be obtained with the help of the 0.95, that is normal probability law. With the normal probability law, which means the areas of the standard normal distributions or probability of standard normal distribution, 95% values are 0.95 corresponding to the probability 0.95. We will have this particular Z value, we can be obtained from the standard normal distribution tables as 1.645. So you see the tables, you will get this value. You correspondingly, you see the 0.95 probability, corresponding Z value is 1.645. Therefore, I write directly, therefore, Z is equal to Ts minus Te divided by sigma E is equal to 1.645. Now what you have to write the values? Ts is the question mark, okay, and Te is equal to 19 days. You see the next, I'll show the next page, and sigma E is equal to square root of 9.11. Okay, I'll see both these values Te and sigma E in the next page. Like you see here, we have just calculated in the fourth question 19 days. It is nothing but Te. Okay, that is total number of days of the completion of the project. The expected time of completion of the project is 19 days and sigma square E is equal to 9.11. Sigma square E. Therefore, from sigma square E, we can calculate sigma E by taking square root. That is sigma E. TE is equal to 19 days and sigma is equal to square root of 9.11. And the value for answer for this is 3.02. So, by substituting these values, we can now calculate the value of TS. TS we have to calculate. So, therefore, TS minus TE. TE is 19 divided by 3 point, sigma is 3.02 is equal to 1.645. By solving this, we can calculate TS is equal to 19 plus 3.02 into multiplied by 1.645 is equivalent to the answer. For this is approximately, this is 23.97, approximately 24 days. So therefore, this is approximately 24 days. That is the 95% of chances we have to complete the project is 24 days. Within the time of 24 days, we can complete the project with 95% chances. 95% of chances of completing the project within the duration is 24 days. Okay, so that is what the question is given, asked in the last question, that is fifth question. So this is what the calculation of the PERT calculations for the given problem. Hope you understand. Thank you very much.